Hi all. Today we will be discussing the problem 145 of Leetcode binary tree post order traversal. So let's read the description. Given the root of binary tree, return the post order traversal of its nodes values. Uh, I assume you know what binary tree is, but let's check how a binary tree looks like. Usually, a tree is generally a hierarchical structure. Assume like it has a root node, that is the starting point of the tree, as 0. Let's index it as 0, or let's keep the value as 0. A binary tree is a tree which has at most 2 nodes as children. For instance, like here, the node which is labeled as 0, that is called as root node, and it has only 2 children. It doesn't have, it can contain 0 children. Then it will be like a standalone node, or it can contain one child, or it can contain 2 children. So this is known as binary tree. So it holds the same for its children as well. These children themselves have are parents to other childs. So here the same thing is happening, like they themselves have nodes limited to 2. Also there is a scenario like they can also contain something like that, like this, like in case if there is 4, if we consider this node 4, it can have just one child. It need not be two children there. We are just talking about binary tree. There are like other trees as well, but we are not concerned about them for now. So yeah, so let's assume these are the trees we are having currently. Okay, so like now how to get the post order traversal of this tree. There are other traversal mechanisms as well, but let's just be concerned about this thing, this post order traversal. So like what will be the sequence for us in which we'll be getting the nodes when we use post order traversal. So let's start at 0. So 0 is a root node. It has 2 children, 1 and 2. So initially what we should do is traverse to the left side of traverse towards the left child, later to the right. So let's try to traverse to the left side. So we entered 1. Let's check that whether this is having any children or not. Yes, it is having few children. So let's traverse it again to the left. So we are just doing it recursively. So like first we started at 0, then we entered 1, then again we reached 3, and we'll be checking like again like whether we are having any children or not. And yes, again 3 is having 2 children. So now we entered 7. For 7 there are no children. So what we'll be doing is we'll be printing 7. So generally how post order traversal works is, first we'll be printing both the children, that is 7 and 8. Then we'll be printing the parent node, that is 3. So if you start printing it here, if you start writing what sequence we'll be printing it, first we'll be adding 7 to the list. Then we'll be going to the right node. First we'll be printing the left node, second we'll be printing the right node, that is 8. Then we'll be printing the parent node of these 2, that is 3. Now since all these 3 are covered, now we are going to the parent node, that is 1. Now again, since we covered all the nodes of 1 from the left child, now we'll be entering the right side. Sorry, yeah, my mistake. Like we shouldn't be adding 1, because like we should cover, as I said, we should cover both left side and right side children, and then at the last we need to add the root. So the sequence will be 7, 8, 3. Now we covered all the left children of 1, so now we'll be going to the right children, that is 4. 4 is having children, so now let's go to 9, and since 9 is not having any children, we can print 9. Then later we'll be adding 4 as well, because we covered all the children of 4. And now since both the children and their children were covered of 1, so now we'll be adding 1. The same sequence goes, and it should be something like 5, 6 and 2 and 0. So this will be the post order traversal list we formed when we traverse using the algorithm. So now let's write the same algorithm through code. Okay, so now let's start writing the code. Here initially I created a list so that we can store whatever the nodes which are there. We can add every node to the list, every node value to the list, so that we can return at the end in the sequence of post order traversal. So first I just made sure that the root is not null. If it is null, we are just going to throw an empty list which we created here. Now I created another new method which returns void, just to add just to iterate or traverse through different nodes of the tree, and we are just going to add on the basis of post order traversal. What we can do, first the algorithm is simple, which I said. So let's write. Let's see how we'll be going forward. Dot write equal null. So if the root is not having any children, then we are directly going to add. Then assume, like as I said before, in case if there are no children, we are directly going to add the node, or in case if both the children are covered already, then we are going to add the node. So we're doing the same, like in case if the node is not having any children, we are going to add it to the list. List dot add. We are going to add the node. So and we are going to have two other conditions. And of course we are returning it. And now we are going to have two other conditions, like whenever we have a left child, we are always going to iterate to the left, and unless it doesn't have any other child. So like our priority of looking is towards left. In case if we don't have left child, then we are going to go to the right child. So we're doing the same. In case if we are having a left child, what we are going to do is we are going to traverse to the left child recursively. So we are just using recursion here. Now I mean to the left. Now we are going to do the same but for the right child. Traverse root dot right. Okay. Now, once we traverse to the left and right child, and once we, once we reach the leaf nodes, we are going to add them here. We are going to add them here. But once the leaf nodes are covered, we should add the parent nodes as well. So after we add these child nodes, then we need to add since then we need to add parent nodes. So uh, here we are going to add the parent nodes to the list. So I guess this should work fine. Let's oh sorry, this should be root dot value. Turn the list. Yeah, I guess now this should work fine. Hmm. Yeah, it is working fine. So yeah, I guess I hope this helps. Yeah, I'll be back with another problem, maybe another daily problem. So thanks.